Okay, good evening, everybody. My name is Dennis Kelly. Welcome to this evening's presentation on sustainable aviation policy, strategy and priorities. I'm a member of the Energy, Environment and Climate Action Division of Engineers Ireland, and I have the pleasure this evening of introducing Professor Marina Efthymiou from DCU. Marina is a leading researcher in the whole area of sustainable aviation. She did her PhD in sustainable aviation. She has published numerous papers and co-authored numerous papers in this area and is heavily involved in the master's program on aviation management at DCU. Tonight, she will be covering what would really be for us as one of the difficult to decarbonize sectors, which is aviation, but also a critical sector to the economy. As we know at the moment, we have the whole area around the cap and Dublin Airport, but even more importantly, the leasing side of the aviation business is massive to the Irish economy as well. So without further ado, and without stealing any of her message this evening, I'd like to hand you over to Marina. Welcome, Marina. You have control.
Thank you very much, Dennis. Thank you very much also for the very warm introduction and the invitation. So as you mentioned, we're going to cover a few items today. So I'm going to talk about the importance of aviation for Ireland. I think it's something that we need to come across very strongly as an island nation. Then the second message that I have is looking at aviation and its relation to climate change, but also how climate change affects aviation. And then we're going to continue with the net zero by 2050 and other targets. So more specifically there, we're going to talk about different kinds of solutions like market-based measures, the emissions trading scheme, and the carbon offsetting and reduction scheme for international aviation. We're going to talk about aircraft technology, bring some examples from operations and infrastructure improvements, and last but not least, the hot potato, sustainable aviation fuels. Okay, so let's talk a little bit about the importance of aviation for Ireland. So Dennis mentioned at the beginning that Ireland is a hub for aviation. It's the home of the biggest leasing companies, aircraft leasing companies. It's home of one of the biggest airlines, Ryanair, that has been a pioneer in the low-cost carriers business model. Aer Lingus with a very strong brand. Other new type of airlines like Emerald, Dublin Airport, Shannon Airport, Cork Airport, and a number of other strong players in aviation. So I have here some figures. I want us to look first at the figure on the right. So on the figure on the right, this is a study that looks at the contribution of aviation and tourism in a national economy. So the footprint it has in terms of GDP. As gross value added as a percentage of GDP, to be more specific. So we see that the world average is something around 3 to 4%, and we see Ireland being above the world average, which means that air transport and tourism for an island nation is extremely important for Ireland. 99% of the international tourists, they come via air. When you want to go on holidays, you have to take a flight. So it's very important to have this kind of connectivity between different kind of origin destinations. Then another way of measuring the importance of aviation is looking at the contribution it has on the economy, also on employment. So we see aviation at a global level contributes to the GDP of $4.1 trillion when we start adding there the aviation direct, indirect, induced, and catalytic effects. Also, it is employing 86.5 million people. When we look in Ireland specifically, we have 44,000 people directly employed, generating $5.6 million of economic output, which is equal to 1% of the GDP. So when we start adding the wider supply chain, the employee spending, and the tourism, then we see that it's raising to $20.2 billion and contributing to GDP by 3.7% of the GDP, and also employing 128,000 jobs, including also tourism there. So as an industry, it is very vital for a national economy, but especially for Ireland. Okay. Then let's now move on a little bit to the climate change element. So we said that it has significant economic and social contribution, but the other side of the coin is that it contributes to climate change. So on the right side here, we have a figure that looks at the various sectors and their contribution to the greenhouse gases. So when we look at transport, that's around 16%. When we look at air transport, that's around 2% in terms of man-made CO2 emissions. So that number of the 2% that came out in 1999 from the Intergovernmental Panel of Climate Change, and as a percentage, it hasn't changed in the last years. But considering that air transport every 15 years is doubling and the growth in the industry, we see that this percentage might rise to 3% in 2050 if aviation does not decarbonize. Okay, so CO2 is one of the main contributors to climate change that we do have a very solid scientific understanding on how it works, how long it lives in the atmosphere, and how it interacts with different other kind of gases. Then there are other kind of elements like the non-CO2 effects, so like NOx, for example, particle matters, SOx, water vapor, which leads to the formation of contrails. So those kind of contrail cirrus clouds, they contribute significantly to climate change. So if we look at those, we see that CO2 is responsible for 1/3 of climate change, and the non-CO2 effects are responsible for 2/3 of climate change. Also, something to note is that CO2, irrelevant of where it is burned and where it's the fuel where it's burned and where it's emitted, it will create around 3.15, 3.16, 1 kilogram of fossil fuel will generate 1.15, 1.16 CO2, irrelevant of where it is emitted. But when we look at different kind of non-CO2 elements, they will depend on the altitude that are emitted. So therefore, aviation is becoming an even more difficult to control in terms of climate change. Then another important thing to keep in mind for aviation is that for the 80% of the aviation fuel used on passenger flights, there is no alternative above the 1,500 kilometers. You cannot take a train in most of the cases. You cannot take a car or a bus or anything. So a lot of the emissions are coming from trips that there is no suitable alternative substitution for transport. Okay. So if we look a little bit on few more figures here, and this is statistics that are coming from the European Aviation Safety Agency. So I have gathered here the reports of 3 different years. So we look at 2005, 2019, and also 2023, which is again from the latest report of 2025. So what we see is that we have one KPI, one key performance indicator on the number of flights. And we have seen that the number of flights has continuously been increasing. And we don't count there the COVID years, but we have recovered from the COVID years. At the same time, aircraft are becoming more fuel efficient. So we see that the average fuel consumption in 2005, for example, it was 4.8 liters fuel per 100 passenger kilometers. And now we're at 3.3, which is a significant improvement. And in the coming years, it will become even better, dropping to 2.9. But at the same time, we see that the full flight CO2 emissions, they're going to jump from 133 million tons to 144 tons. And when we look at the full flight NOx emissions, they will jump from 644 to 726. So the NOx emissions, they have been growing even faster than the CO2 emissions, and they're expected to continue with this growth. And considering the non-CO2 effects, that's something we really need to look at. Okay. So maybe one concern that sometimes we have is, do we really need to decarbonize? Decarbonization is something that will increase the ticket prices. It is one of the most difficult industries to decarbonize because of the long lifespan of the asset, the aircraft, that they will be in circulation for 20, 25 years. So do we really need to decarbonize air transport? Also, we decarbonize the other sectors. I will say that there is a very strong business case towards that. So there have been evidence that, of course, climate change causes a number of welfare elements issues, like, for example, it threatens the food security. We have seen being a cause for migration and human conflict. So, for example, extensive droughts have displaced farmers. It is very much connected with significant health effects for both people and animals. And we see more natural disasters because of climate change. We see 3 and 4 times more typhoons and extreme weather phenomenon like that currently happening. You see that in the news in the last days down in the Philippines, for example. But also, climate change has a significant effect in the operations of airlines and airports. So we see sea level rising, and it's threatening low-lying airports. We see unpredictable weather that creates a lot of delays, which is, of course, a cost for the airlines and is not a pleasant experience for the passengers either. We see higher temperatures, maximum at the ground level, which decreases the air density, reducing the lift force of the departing aircraft. So that means that the payload, passengers or cargo, has to be decreased. We see greater levels of moisture and higher temperatures that can cause icing of the aircraft, delaying again the turnaround of the aircraft, increasing the cost for the airline operators, and maybe causing delays. Then we see significant changes in the jet streams. So that means that if I want to go to the US from Dublin, it will take much longer in terms of time. The route will be different and it will burn more fuel. And burning more fuel means more emissions. Then we also see climate change being also responsible for clear air turbulences that cannot be detected. And we have seen significant safety incidents because of cabin crew or passengers being injured during flights. So it has a very strong relation towards affecting the operations of the airlines and the airports. So we should definitely decarbonize air transport because it has all of those implications that maybe we haven't really considered them yet. And then I have one more slide that looks at the economic rationale. And I think that's mainly my slide towards the new administration in the US, maybe. I don't know. So we see the economic rationale towards the decarbonization. So reducing global emissions over the next 50 years to meet the Paris Agreement goal that said that we want to keep the increase in the temperature under 2 degrees of Celsius, ideally 1.5 degrees by the end of the century, will prevent in the US alone 4.5 million premature deaths. The avoided deaths are valued at more than $37 trillion. The avoided healthcare spending due to the reduced hospitalization and emergency route visits exceeds $37 billion. And an increase in the productivity of the labor is valued at more than $75 billion. Academic research has found those figures. And again, that's a very strong indication that we really need to control climate change in general. But speaking a little bit more about aviation, so we have here a series of photos. My main point here is that we should not take for granted that aviation should constantly be expanding without really accounting for the negative externalities. We have significant mobilization of the social community around the world or also close by where they might revoke the license to operate. So again, that's a very strong message towards aviation that needs to decarbonize. Okay, and I think aviation is hearing this message, and it's one of the first industries that took a commitment towards decarbonizing. So voluntarily, the aviation world has agreed to the net zero emissions. So they have agreed to overall balance between CO2 emissions released and emissions removed from the atmosphere. So they have a target that by 2050, they will reach the net zero. What I need to say here is that this target is an aspirational target, an ambitious target, and it's not a mandatory target. We have a project currently called A025, where we are simulating the various initiatives that the industry has been taking, and also the annual compound growth in order to see if 15 airline groups in Europe, they will be reaching net zero by 2050. I don't have an answer yet for that, but if you want to follow more about that, you can use the hashtag #Azero2050. And when we have found the solution or the result of that, I'm happy to share that with everybody. So now let's see a little bit what's the initiatives or the strategies on how aviation can really reduce their emissions and ideally reach the net zero. So there has been a very kind of intensive and comprehensive analysis of looking at various scenarios. More than 75 scenarios were produced for the Waypoint 2050 report. Here I'm presenting the three main ones. So when we look at decarbonization, the options are in the basket of measures, let's call it like this. So we can look at improving the aircraft technology. So we could look at improving the fuel technology, looking at sustainable aviation fuels, for example. We can look at improving of operations, the way we fly the aircraft, improving the infrastructure, like airspace optimization. And we can also look at market-based measures like carbon offsets, for example, or carbon capture utilization and storage. So depending on which of those solutions is going to scale up faster, we have different reliance on those kind of solutions. But all the scenarios, what they agree on is that sustainable aviation fuel is one of the most promising options for us to decarbonize. And technology, while we see that being advancing more and more, that advancement curve is getting a little bit more flattened. So it's more and more difficult nowadays to increase the fuel efficiency, to think of new aircraft configurations and airframe designs to reduce the emissions. So a simplified version of what I showed earlier on is the IATA roadmap, where we look that 65% of the decarbonization is going to come from SAF, 13% is going to come from new technology, and that includes electric aircraft or hydrogen aircraft. 3% is going to come from operations improvements and infrastructure, and 19% is going to come from offsets and carbon capture. Okay, so let's see another measure that has been applied, green taxes. So a number of countries, not Ireland, have implemented emission charges. So we see, for example, Sweden, for example, applied a carbon tax in 2018. They abolished that on the 1st of July 2025. In 2020, we had the French carbon tax that, again, depending on the class that you were flying, they will be charging you a different fee for your domestic or intra-European flights. Similarly, we have the airport passenger duty in the UK, which was not designed as an environmental tax, but nowadays it has been aiming also at addressing the environmental impact. There are various opinions on their effectiveness. Me personally, I think that depending on how high those are, you might be able to change behavior of aircraft operators, but depending a little bit on your geography and also your market share. So if you are, for example, an airport in Barcelona that you're relying heavily on a specific airline, if you are implementing such a tax, then the airline might be deciding to deploy their asset at a different airport, at a different country, where they don't have this cost. So then you haven't really changed the behavior at a total level. It's just that you have displaced those emissions happening in a different country. But it can also be a very good way of revenue generation for climate change mitigation for airports. So let's hold that thought maybe a little bit. Another example is when we look at infrastructure improvements. So we have here the example of air traffic management. In Europe, they realized 2 decades or 3 decades ago that the airspace is quite fragmented. So they found that on average, its flight is 49 kilometers longer than the direct flight, that the great cycle distance, that it's the shortest distance between origin and destination. So they found that the airspace was quite fragmented, that we have several air navigation service providers, that they don't always communicate very well. So what they came up with is maybe let's force them to collaborate. So they put UK and Ireland together and they form the UK-Ireland Functional Airspace Block. So that optimization, what meant is that we had significant savings. So that optimization estimated that the UK-Ireland FAB will deliver savings of 48,000 tons of fuel, which is 152,000 tons of CO2. Not an inconsiderate amount. So after 2011, from 2020, we see the annual savings rising to 111 tons of CO2. So that's an example of how improvements in the infrastructure can reduce CO2 emissions. So in essence, what they did is better routings within the UK and Ireland airspace. Okay, then another measure is, I will simply call it carbon offsetting. The term we use is market-based measures, but significantly it has inside the carbon offsetting mechanism. So ICAO, the International Civil Aviation Organization, which is a United Nations body, they came with an agreement that by many it has been criticized of not being ambitious enough, but to my view, having an agreement at an international level, it's already an achievement. So what they said is that we're going to start looking at having different countries offsetting their international flights. So it started at an initial pilot phase where the European Union volunteered to participate, and later on it's becoming mandatory for all the member states of ICAO. So all member states and the airlines operating within them will need to be doing carbon offsetting for their international flights. Obviously, there are some exemptions for landlocked countries and small island nations. This does not include Ireland. Ireland is having to follow the ICAO CORSIA. Then in Europe, we have the emissions trading scheme. And in 2012, aviation has been included in the European Union emissions trading scheme. So that scheme is like a cap and trade system where a number of allowances are allocated to aircraft operators. Initially, many free allowances based on grandfathering rights were given, but gradually now we see them being phased out. So that means that the airlines, they will need to buy all their allowances. An allowance is a right to emit 1 ton of CO2. So that means that they need to find ways of decreasing their emissions, either through renewal of their fleet or optimization of their flights, or doing carbon offsetting, buying those allowances from other players within aviation or outside of aviation. And we see that the price of those allowances over the years have been increasing. So jumping from 60 euros per ton in 2021, now we are at 85. And that scheme also start adding at the monitoring, reporting, and verification phase the non-CO2, which is again an excellent addition as we're raising a little bit our awareness and creating the database for later on also regulating the non-CO2 emissions. Then now I'm going to move a little bit to the hot potato, and I'm going to stay here for a while. So CORSIA and TTS, they recognize when an airline will use sustainable aviation fuel in order to offset their emissions. So we have 3 different terms here. We have sustainable aviation fuels, co-processing, and low carbon aviation fuels. Those are quite different, and I want to make sure that we all understand a little bit their differences. So when we talk about SAF, the feedstock is non-fossil, and all the savings coming from the use of sustainable aviation fuel is coming primarily from the life cycle, which is associated with the feedstock. When we look at low carbon aviation fuel, we talk about fossil fuel, but during its production of the fossil fuel, we have seen different emissions reduction. So for example, we can have extraction of fossil fuel using alternative energy. So that can lead to a saving on the whole emissions of this fossil fuel. In order to qualify as a low carbon aviation fuel, it needs to be 10% less emissions than Jet A1 conventional fuel. And then we have something that stands in the middle. So we have co-processing, where again the feedstock is the non-fossil blended with the fossil. And all the savings by using this type of fuel is coming from the life cycle of the feedstock of the SAF. Then, when we look at the different types of SAF, not all SAF is the same. So the feedstock can be very different. And also the technological pathway for producing the SAF can be very different. So currently, 99% of the sustainable aviation fuel that it's out there is coming from HEFA. HEFA stands for hydroprocessed esters and fatty acids. The feedstock from that is recycled oils, animal fat, and bio-oils. And we can blend 50% of that in our engine. So this type of fuel, the sustainable aviation fuel, is a drop-in liquid that uses the same infrastructure and can be blended up to 50%. But again, different types of SAF, they might have a lower blending ratio to our engine for us to burn it. And they can have significant savings. So what is interesting with sustainable aviation fuel is that we have different types of feedstock and different types of pathways. So we have more than one feedstock aligned to more than one pathway. So if we're looking at the national level, the first thing we need to see is what kind of feedstock we have. So if, for example, we have forestry waste and residues, this type of feedstock can be processed either with alcohol to jet or Fischer-Tropsch. So depending on which one is maybe cheaper and scalable and what kind of infrastructure we might want to develop, a national country might decide to look at investing at this type of feedstock and technological pathway. So in essence, those are like the chicken and the egg situation. Then another parameter very important when we start evaluating a sustainable aviation fuel is the emissions reduction factor. So different type of feedstock can lead to different carbon reduction compared to the conventional jet fuel. So for example, we see that canola is a terrible biofuel because it does not reduce the emissions significantly, whereas used cooked oil can have carbon reductions compared to the conventional jet fuel of the rate of 80%, which makes it a very suitable type of feedstock. Okay, then if I challenge you a little bit with something very important here, when we look at the aircraft and the fuel technology, we have different type of aircraft serving different type of markets. So we can have commuter traffic, which means that we have aircraft of 9 to 50 seats flying for 60 minutes. They represent only 1% of the industry CO2. So for this type of aircraft, we can have electric aircraft or hybrid electric, meaning that aircraft taking off with batteries, or hybrid that they will take off with fossil fuel and they will cruise with electric. So we can have this type of aircraft in the market very soon. When we though start looking at the more meaningful emissions reduction, so when we start looking at medium haul and long haul, which combined represent 73% of the CO2 emissions, then we do not have the technology yet for having electric aircraft. Then when we look at hydrogen fuel cell type of aircraft, Airbus had their zero aircraft that they were hoping to be commercial by 2035, having their test flights in 2027. Those plans have been postponed. But even those plans, if they were still happening, they wouldn't be enough to carry a lot of passengers and serve short-haul, medium-haul, and long-haul flights due to the energy density ratio. So they cannot carry a lot of payload. So when we look at where we stand in terms of aircraft technology, both in terms of the type of fuel that they use, we see that they are not there, and they will not be there by 2050 for the majority of the missions. So it's not enough, and therefore that's why we rely more and more on sustainable aviation fuel. So hydrogen fuel cell is a type of aircraft. Then we have something else that uses hydrogen. So we talk about e-fuels, synthetic fuels, or power to liquid. So this is another type of sustainable aviation fuel, which is composed of synthetically produced liquid hydrocarbons. So again, a drop-in fuel. This type of fuel, though, has some challenges behind it. So we need a lot of green hydrogen, and a number of countries don't produce enough green hydrogen. They haven't sorted out their renewable electricity, let's call it like this. Then also to create the power to liquid, we have significant energy losses, and that makes the power to liquid several times more expensive than the fossil fuel. So if SAF is 3 to 4 times more expensive than fossil fuel, e-fuel is 10 times more expensive. We have significant scaling limitations, so a number of projects, they don't scale up. It's a very risky investment. They're hesitant to be the first in order to create ESAF. And again, when the renewable energy is not there, they face significant sustainability challenges. So there is also the infrastructure and market barriers. So we have competing demand for renewable. So that means that we lack the mature supply chains, and they will slow the certification process in order to scale up and develop power to liquid. Something that has been creating a little bit of certainty in the market for the uptake of SAF is the regulation. So we have two types of regulation. We have the regulation that will incentivize the demand, meaning subsidies, like the Inflation Reduction Act in the US, where producers, they are provided a subsidy for producing sustainable aviation fuels. Or we can have a more kind of different type of regulation where we're implementing a mandate, a minimum blend of sustainable aviation fuels. This is the route that the European Union and the European Commission decided to follow. So we have a regulation commonly known as Refuel EU. So that regulation, what it says is that we need to have 2% of SAF blend in 2025. That percentage will start raising to 6%, where at that time we also see other sub-blending mandates on synthetic fuel, ESAF, being also imposed. So that starts scaling up quite very kind of fast from 2035, where we are raising at 20%. And by 2050, we're looking at 70% blend of SAF. 35% of that needs to be the conventional SAF, and 35% needs to be synthetic fuel. So to conclude and sum up a little bit, some of the points that I have been considering in the last, I don't know, a couple of decades that I have been working on that is some people will say aviation only contributes to climate change by 2%. Should we do something? Of course we should do something, because if all the other industries are decarbonizing faster than aviation, and aviation again is a difficult to abate industry, that percentage will jump. And then it's also the critical question, what happens if we don't do anything? Okay. Then the other point is that we have been focusing on CO2 because we know that it lives in the atmosphere for thousands of years, but now we have a better scientific understanding on the lifespan of other gases and also their interaction. So we need to start looking more on the non-CO2 effects. because they do matter more in terms of contribution to climate change. Having said that, we need again to consider the wider implications. So decarbonization is a cost. We don't want to go back to increasing fuel prices and increasing the ticket. So therefore, we need to consider effects on tourism, effects on national economies, and especially effects for island nations like, for example, Ireland. So some of the things we need to look at is what is the most effective way to decarbonize, what's the solution that will have an actual impact, but also the efficiency on the way of doing it, what's the marginal abutment cost for that, and also the feasibility of all of those measures. So on that note, I would like to thank you very much, and I will go back to Dennis.
Wow,
That
there's
was
a
a sprint.
huge amount of stuff, absolutely massive amount of material covered there. I would thank you very much for your session this evening. I found it fantastic. I've worked in aviation in the past and I've worked in energy, so the whole area really fascinates me. And I think it's a big challenge for as an industry, it's going to be really complex. And another area I most certainly would hope to get a speaker on in the near future is in the whole marine side, which is the twin brother or twin sister of the aviation industry, another very hard to abate
Similar
sector.
problems.
It exactly. I mean, you think of problems in
Yeah.
aviation. Wait till you see marine, but they say the same about you. But we won't go there. But I think it's two critically important sectors for society in general. But we have to address the emissions, and we have to move towards green. And I think you hit some really good points around getting governments on the same page, giving certainty to the industry, then actively encouraging more research and more development, and I suppose financial incentives to move down towards the decarbonization. Look,
There is just
fantastic
one
session.
there. Also, there is government, and congratulations to them for that. It should have
Mm,
happened sooner, but anyway,
yeah,
they now have the SAF roadmap. So if people are
exactly.
interested, they can look at the Department of Transport and see where Ireland stands in terms of SAF.
Excellent. That's an excellent, well worth a look, I'd say. And this, and I suppose even researching with yourself around this one earlier on, just to get the material for the presentation. I was doing some reading behind the scenes, so I would be totally ignorant talking to you. Um, this it's a fascinating sector. It is. There is so much going on, and there's so many lively debates ongoing, whether it's contrails or SAFs or hydrogen or whatever. And then there's all these different aircraft people are promising and all sorts of things going on. So it's a sector, I would say, if anybody's interested in, keep an eye on this sector. It's critical to the economy, but there's an awful lot going on at the same time. Look, thank you very much again, Maria, for your session.